All right, so we're done with that activity. Give me 1 second. All right, let's summarize it. So the vertex form looks like y is equal to, well, f of x is equal to a times, I'm going to make a slight change over here, which is this. I'm just going to make it x plus h quantity squared plus k. In the previous page when we did that activity, it was x minus h. I'm changing up because this is something that we're more familiar with it than the one how we did it previous page. Okay, all right, so first let's talk about the translation piece of it. So translation from the parent function y is equal to x squared, you can move it up and down, you can move it left and right. All right, so how does that go? The k number is vertically shifting up and down, so when k is positive, that's you're moving it k up. If k is negative, k down, so that is up and down. All right, what about the h? H is the inside of the parentheses with the x, left and right. So if the h is positive, so for example, x plus 3 squared, that's what? Left. Well, h left. If h is minus, so for example, x minus 3, that's 3 right. So h right. Where is going to be your vertex? Well, I can't spell. Vertex is negative h comma k, where it's the opposite sign than whatever is over here, and then the last y value is going to be same as the shifting up and down value k. Okay, what else? This number a over there tells you two important things. What were those? Number one, it tells me about the direction. So on the previous page when we did the activity, remember what happened when a is changed to negative value? It flipped across the x-axis, so instead of it being the parabola smiley face, it is frown upside down. So when a is positive, it's the opens up. So it looks like this. If a is negative, it open down. I don't even know that's how you say it. Open down. Upside down, frown face. So if it's a positive, U. If it's negative, upside down, U. A value also tells me about the width. Okay. What happened when A was between 0 and 1 and 0 and negative 1? Your graph was wider than the parent function. Do you know any other way I can say a number between 0 and 1 and 0 and negative 1? We're going to use the absolute value of A. So if the absolute value of A is less than 1, which is same as between 0 and 1 and 0 and negative 1, it's going to be wider than the parent function. If absolute value of A is greater than 1, like over here when A was greater than 1 or less than negative 1, it was narrower than the parent function, it's going to be narrow. Oops, sorry. Yeah, narrow than the parent function. What if absolute value of A is equal to 1? Like what if it was just equal to 1? It's the same width as the parent function. Same width. So it also tells you about the width. Okay, all right, very, very important over here. Let's practice. Identify all these things. All right, so I have it over here. Let's first find the vertex. How do you find the vertex? X minus 1 is 1 to the right, so it's going to be 1 by x value, or it's the opposite of that right there. So if it's a negative 1, it's going to be plus 1. Comma, what's the y value of the vertex? 3. X's of the symmetry is going to be the same as the x value of the vertex. X is equal to 1. What else? Direction. What value should we pay attention? A. Your A value is 4. So since A is positive, right, 4 is positive, it opens up like this. What about the width? What is the absolute value of 4? That is 4, which is greater than 1. Okay, so when absolute value of A is greater than 1, it is what? Narrow. What else? Domain. Any quadratic function, domain is always negative infinity to positive infinity. Range, I'm going to use a graph to figure it out. So what I'm going to do here is I'm going to sketch this function. Where is the vertex? 1, 3, 1, 3, 1, 3. Over here, narrow opens up. So it's going to be a narrow open up. So there is a sketch of the function right there. What's going to be the range? Range is a y value, bottoms up. So where does it start? It starts at 3 and above. So your range is going to be y is greater than or equal to 3. Okay. One more thing. X's symmetry was x is equal to 1. Which makes sense because it is at x is equal to 1. That line is what it cuts in half and fold it. Cool? Alright, I'm going to do letter B with you in a class. Now, graph a quadratic function below using the table. Okay, so the first thing you're going to do is you're going to make a table, find a vertex. Okay, so what is the vertex of this f of x right here? X plus 1, so negative 1, comma, 5. Cool? Alright, so put your dot at negative 1, comma, 5. And you're going to pick 2 more x value on the same side of the vertex. And find y. Some of you have done this before actually in Algebra 1. So x and y. What was the vertex? Negative 1, comma 5. So I'm going to pick 2 more x value that's bigger than negative 1. Okay. Can I do 0? Can I do 1? Yeah, 0 and 1 are good too. So 0 and 1. So pick those 2. Now what? Take those 2 values and then plug it into your function to find the y value. So take the 0, plug it in. So negative 2, 0 plus 1 square plus 5 is PEMDAS, parentheses, 1 square is 1. Multiply, you're going to get 3. So you get 0, comma 3. What about 1? Negative 2, 1 plus 1 square plus 5 is PEMDAS, 2 square is 4, negative 8 plus 5 is negative 3. Okay, so let's put those points. 0, comma 3. 1, comma negative 3. And now what? Step 3, oops, reflect over axis of symmetry. Well, what do I mean by that? What is the axis of symmetry for this quadratic function? X is equal to negative 1, the x value of the vertex. So I can go ahead and draw a dashed line at x is equal to negative 1. And what you're going to do here is you're going to take those 2 points that you got and then reflect it over that line. So that point and this point. This point reflected over that line, you get to over here. Why can I do that? Because remember on the front page, we learned that, we learned that your values are symmetrical to one another, and axis of symmetry is what makes the half of the graph folded to the other. So that's a property we're using here. So I take it, reflect over the axis of symmetry, I take it, reflect over axis of symmetry, and then you connect them. Cool? Let's find the domain and range as well. Quadratic domain is always negative infinity to positive infinity. Range, notice the smallest y value is negative infinity all the way. It stops at 5. In other words, your y has to be less than equal to 5, which is a little different. Cool? Alright. One more. Over here. Write a quadratic function in vertex form if given its graph. Okay, so we're going to go backward. You have the graph. You're going to come up with the equation. First thing, identify vertex, which is right here. So what's a vertex? 2, negative 5. Step number 2, pick another point. And then pick a one that's on the grid. So like you can do this one. That's a bad choice because that's the fraction or decimal, so I can't really tell what the x value is. So pick the correct one. In this one, I'm going to do 3, negative 6. Okay. All right, number 3, plug vertex and another point into y is equal to a times x plus hk plus square plus k. All right, so actually, I don't like this. If the vertex is 2, negative 5, and I want to plug it into the form, which looks like this, how would that work? Well, x value is 2, so wouldn't it be x minus 2? Right, so y is equal to a x minus 2 squared. Y value of vertex is negative 5, negative 5. You good? Once again, so I'm using the basic form here. If x value of vertex is 2, x minus 2, negative 5, negative 5. And then you take that 3, negative 6, plug it into x, plug it into y. So negative 6 is a times 3 minus 2 squared minus 5. Negative 6 is a times 1 squared minus 5. PEMDAS, 1 squared is 1, 1 times a is a. Add 5, a is negative 1. So that means the final vertex form is going to be y is equal to, plug that negative 1 in here. Negative 1, x minus 2 squared minus 5. It's going to be the correct vertex form. Okay? All right. Very good. Thank you for paying attention. We are going to do those problems that we did not do in class as a review. Okay?